Hello guys, welcome to my channel NCERT Unplugged, and in this video I explain you article number 5.2.1, the magnetic field lines. Okay, as we have seen in the first chapter there were electric field lines. Okay, so electric field lines are a representation of electric field. Okay, similarly magnetic field lines are a visual representation of a magnetic field. Okay, here also the line is given, the magnetic field lines are a visual and intuitive realization of the magnetic field. Okay, and the pattern how magnetic field lines are we have seen in the previous video. Okay, like this. But if we sprinkle iron filings on a glass sheet which is placed over a bar magnet, there the magnetic field line will show up. Okay, and now the pattern of iron filings permit us to plot the magnetic field lines. Okay, there's some note is given. You can see this note in some textbook. The magnetic field lines are called magnetic lines of force. This nomenclature avoided since it can be confusing. Okay, will not here magnetic lines of force are not used for magnetic field lines. Okay, unlike electrostatic, the field lines in a magnetism do not indicate the direction of the force on a moving charge. Okay, when we study electric field lines, we see that what happens in electric field line, as you can see also here, there is a dipole here. Okay, and the electric field is given. Okay, if we place what is the direction of electric field is at this point, draw a tangent, and the direction of the force will be the same. Okay, the force on a test charge will be same, but this is not the case here. Okay, the force point, there is a point, the magnetic field, direction of magnetic field will be like this. Okay, but the direction of force on a moving charge at this point will not be this. Okay, it will be perpendicular, as we know from our previous chapter. Okay, so this is a difference. Okay, we are not using magnetic lines of force here. Okay, for magnetic field lines. So now, and this is shown both for the bar magnet and the current carrying coil in figure. For complete refer to chapter 1. Okay, electric field lines of an electric dipole also displays. Okay, so you can see there are three diagrams. The first diagram is of a bar magnet. Okay, second diagram is of a solenoid. You can see this is solenoid, and third diagram is of a dipole. Okay, magnetic field lines in case of a bar magnet, this is in for a solenoid, and this is for a dipole. Electric field lines for dipole. Okay, you see that the magnetic field lines for both solenoid and bar magnet are almost similar. Okay, and this is similar to a electric dipole. Okay, so we can relate them. Okay, we can compare them. And now you see we'll discuss the property of this. So first property is the magnetic field lines of a magnet or a solenoid form continuous closed loop. Okay, you can see from the diagram they are forming continuous closed loop. They are formed like this. You see they are closed loop. Even this is closed loop. Okay, what does that mean? It means that, like you see in electric dipole, it starts from positive and in negative. Okay, they are not closed loop, open loop. But in case it start from north, if it is not starting from anywhere, if I take from north, it goes to south, and then it again comes to north. Okay, so it is forming a closed loop. So this is a difference between electric field lines and magnetic field lines. Okay, so now the second point, the tangent to a magnetic field line at a given point represents direction of the net magnetic field at that point. Okay, so if I draw tangent at any point in a magnetic field line, that will represent the direction of the magnetic field at that point. Okay, now, but not the direction of force on a moving charge, as I already told you. Okay, now third point is, the larger the number of field lines crossing per unit area, the stronger is the magnitude of the magnetic field B. Okay, so you see there are two region here, first and second region. You see in first region the number of field lines crossing this area is very less, but in this second region the number of field line crossing is very large. So the intensity is more in magnetic field. Intensity of magnetic field is more in second case. Okay, second region. Okay, so now third point. Fourth point, the magnetic field line do not intersect, for if they did, the direction of magnetic field would not be unique at that point of intersection. Okay, so this is also similar to electric field lines, that if there will be they do not intersect. Okay, none of the electric field magnetic field line intersect. If they did, what if suppose there will be intersecting like this. Okay, there will be two magnetic field lines, then at the point of intersection the direction of magnetic field will be there will be two direction of magnetic field, which is impossible. We cannot have how can we have two direction of magnetic field? Okay, so it is not possible. Okay, so magnetic field line do not intersect. Okay, it is similar to electric field line as we studied. Now one can plot the magnetic field lines in a variety of ways. One way is to place a small magnetic compass at various position and note its orientation. This gives an idea of the magnetic field direction at various. So there can be many ways to plot magnetic field lines. One way is like this. What you do, like you take a bar magnet, then you place a compass here, magnetic compass here. It will orient in a direction. Then take it in a plain paper. Okay, then with the help of pencil draw a point here. Okay, now move the compass here. Okay, and then again put a point here, dot here with the help of pencil. Okay, similarly the compass will orient itself in certain direction, and that will result in a magnetic field line. You can plot magnetic field line with the help of this. Okay, so that was all for this paragraph. Next paragraph I'll explain in the next video. Okay, thank you for watching. If you like this video, please if you understand from this video, please like this video and share with your friends and subscribe to my channel. Thanks for watching.